question is solve the equation. Solve the equation x raised to power 4 plus 2x raised to power 3 minus 21 x square minus 22 x plus 40 equal to 0, given the difference of two of roots, given that difference of two of its roots is equal to difference of other two. So what is the given statement? So number one, it is a biquadratic equation, so it has four roots. So given equation is x raised to power 4 2x cube minus 21 x square minus 22x plus 40 equal to 0. So this is the equation number 1. Since it is a biquadratic, to its roots are 4 root, let alpha, beta, gamma and delta be their roots. And difference between two, suppose the difference is alpha minus gamma, which is equal to delta minus beta. So difference between these two is equal to difference between beta and delta. It implies alpha plus beta, which is equal to gamma plus delta. It means sum of two root is equal to sum of other twos. Suppose this is treated as constant k. Now by using the beta lemma, the sum of four roots, which is equal to minus 1, 2 over coefficient of x raised to power. So this is 1. So total is minus 2. So it means alpha plus beta and gamma plus delta. It means 2k, which is equal to minus 2. It implies k is equal to minus 1. So it implies sum of root alpha plus beta and gamma plus delta, which is equal to minus 1. So we get the sum of the roots. Now assume that product of the root alpha beta, which is equal to p, and product of the root, so assume that alpha beta is equal to p and gamma delta is equal to q. So the root quadratic equation whose roots are alpha beta, which is x square plus x plus p, and second quadratic equation which is x square plus x plus q. So multiply with each other, x raised to power 4 plus x cube. So this is 2x cube plus px square p plus q plus 1. This is into x square. So what is the x? So this is a px plus qx. So p plus q into x, and what is the product, which is a pq, constant term. Now comparing this equation with equation number 1, so we get p plus q and pq which is equal to 40 and p plus q which is equal to minus 2, 22. Now find the equation whose roots are p and q. So this equation is t square minus sum of root p plus q into t plus product of root pq which is equal to 0. It implies t square plus 22t plus 40 equal to 0. It means this is the equation whose roots are p and q. So it implies p and q, these are roots of the equation t square plus 22t plus 40 which is equal to 0. So it implies this can be written as t plus 2 into t plus 20 equal to 0. So it implies t is equal to minus 2 and minus 20. Now the two roots are minus 2 and 20. So let p is equal to minus 2 and q is equal to minus 20. So we get two quadratic equation. One is x square plus x minus 2 equal to 0. Second is x square plus x minus 20 is equal to 0. So simplify this quadratic equation. So what we get? We get x equal to minus 1 plus minus b square minus 4ac, which is a 8 square root of this over 2. So this is a minus 1 plus minus 3 by 2. So this is a minus 2 and second is 1. Now in this case x is equal to minus 1 plus minus b square 1 plus 80. So over 2. So this value is minus 1 plus minus 9 by 2. So this is minus 5 and 4. So we get 4 roots, which is minus 2, 1, 4 and this. So it implies minus 5, then minus 2, then 1, then 4. So these are roots of the given equation of the given equation 1. Now it satisfies the condition of given condition. The difference between two is equal to difference between other two. So you can check that. So this value will become -5 -1. So this is a -6. Similarly, -2 -4. So this is again -6. So that means it also satisfy the conditions. Now after going to the next question, the sum of two roots, the sum of two roots of the equation x raised to power 4 minus 8x cube plus 19 x square plus 4 lambda x plus 2 equal to 0. So this biquadratic equation has 4 roots. The sum of the two root is equal to the sum of other two and find lambda and solve the equations. Solve the equation. Find lambda and solve the equation. Now again, suppose this is equation number 1 and let alpha, beta, gamma and delta be roots of equation number 1. Root of equation number 1. By given sum of two root alpha plus beta, which is equal to gamma plus delta, suppose this value is equal to k. Now in given part, sum of all the four roots alpha beta plus gamma plus delta, which is equal to minus 8 over 1. So this is equal to 8. So it means 2k equal to 8. It implies k equal to 4. So we get the sum of values. So what is the sum of values? So alpha plus beta, gamma plus delta, which is equal to 4. Now let product of these two root p and product of these two root q. So equation number 1 become x square minus sum of root. So that is a 4. So minus 4x plus p into x square minus 4x plus q. So this can be written as x raised to power 4. Now x cube, so this is minus 8x cube, then x square. So x square is p plus q plus 16 into x square, and next is x. So x is minus 4 P plus Q into X and plus PQ. So this is a constant term. Now comparing these terms with equation number 1, so we get P plus Q plus 16, so which is equal to minus 21, and sec which is equal to what is given. So P plus coefficient of X square P plus Q plus 16 which is equal to 19. So here this term is 19. So this term is 19. Next is minus 4 P plus Q which is a coefficient of X. So this term is plus 4 lambda. 4 lambda, yeah, 4 lambda X. Now first find the value of lambda. Similarly, PQ, this is a constant term, so which is equal to 2. So first we find the value of lambda. Now P plus Q, this value is equal to minus lambda. Substitute this value in this equation. So we get minus lambda plus 16 which is equal to 19. So lambda is equal to minus 3. So lambda is equal to minus 3. So this is the value of lambda. Now again we can find the value of P plus Q. So P plus Q will be 3 and product PQ will be 2. Now to find the value of P and Q, we get the equation. So now P and Q are roots of the equation, t square minus sum of root plus product of root which is equal to 0. So it implies, substitute the values, t square minus 3t plus 2 equal to 0. Now find the value of t. This value will become t minus 1, t minus 2 equal to 0. It implies t is 1 and 2. So root are 1 and 2. So since P and Q are roots, so it implies, yeah, let P is equal to 1 and Q is equal to 2. Now we get two equation. One is x square. So what is plus x square and plus the minus, we check that, minus 4x. So minus 4x plus p is equal to 0. It is one equation. Second equation is minus 4x plus 2 equal to 0. So what is its root? 4 plus minus 16 minus 4 over 2. So this will become 4 plus minus square root of 12 by 2. So this is 4 plus minus 2 square root of 3 over 2. So this is 2 plus minus under root 3. So these are the two roots. Now other two roots, which is 4 plus minus 16 minus 4ac. So this is a 8 over 2, 4 plus minus 8 square root. So over 2, so this is 4 plus minus 2 square root of 2 over 2. So this is equal to 2 plus minus square root of 2. So these are the four root of the given quadratic equation. So the given equation, the roots are 2 plus minus under root 3 and 2 plus minus under root 2. So these are roots of equation number 1. So in this way, we can find the root of a biquadratic equation. Now, if the given equation has root which is in GP series, the GP, the statement of the question is solve the equation. Solve the equation 3x raised to power 4 plus 17 x raised to power 3 minus 5x square plus 8x plus 12, which is equal to 0. So this is a given equation, and being given that product of root is equal to unity. So given that the product of root is equal to unity, also we can say that the whose roots are in GP. So whose roots are in GP. So in the GP, the product of root is equal to unity. Check that. Solution. So what is the GP, which is A by AR square. So this is AR square, and then which is equal to A, this is AR square, and this is, if it is A by R, so this is A by R square, this values. Now taking the product of these roots, so product of these roots are, in case of it is a GP series, the product is equal to unity. So the product is, so this is, so correct the statement of the equation. So in this case, solve the equation given that product of, so given that product of two root is unity. So just correct the statement of the question. Solve the equation. The product of two root is equal to unity. Now solution. So first, what is the given equation? 3x4 17x cube minus 5x square plus 8x plus 12 equal to 0. Now, product of four roots. product of 4 roots, which is equal to minus 1 raised to power 4, 12 by 3. So this is equal to 4. So product of 4 roots is equal to 4. And given that product of of 2 roots, which is equal to 1, it means product of other 2 roots, other 2, which is equal to 4. So here product is given. Now suppose in this case, let P is the sum of 2 roots whose product is whose product is 1, whose product is 1. Similarly, Q is the sum of 2 roots whose product is 4, whose product is 4. So we get 2 quadratic equation. So one is x square minus px plus 1. Second is x square minus qx plus 4. Now simplify this equation, x raised to power 4. Now this is minus p plus q x cube. Now next term is x square. So this is plus pq, 4 and plus 5. So this is a 5x square and plus pq x square. Now x, so which is 1 is minus 4p, this into this minus 4p plus q into x. This is minus into 4p minus this x plus constant term, which is equal to 4. So just we write it in this way. So x square plus px, 1 root, and this value is equal to, and multiply by 3 because it is not a monic equation. So if we multiply by 3, so we get 3x4. This is 3 into p minus q, and this is 3 into pq plus 5, and 3 into 4p plus q, and last is 12. So this is a 12. So these are the our values. Now compare all of these with the given equation. So first term is minus 3 p plus q, and this term is equal to coefficient of x cube 17, and second is 3 into 5 plus pq, and this term is equal to coefficient of x square, which is equal to minus 5, and third is minus 3 4p plus q, and this term is equal to 8 coefficient, and last constant term 12 is equal to 12. So from this we get these kind of equation p plus q. So from this p plus q, this is plus and coefficient of x square, coefficient of x square. So this is equal to 3 coefficient of x square, which is equal to plus 3 into p plus q plus 5, and this values, and here it is equal to plus 17. So this value is equal to this values. Now this is, from this we can find the value of p plus q. So p plus q, which is equal to minus 17 by 3, and from this we can find the value of pq. So pq plus 5, which is equal to minus 5 by 3. So this is pq can be written as minus 20 by 3. So this is a value of pq, and this is a value of p plus q. So from this we can find the value of p and q. So how we can find the value of p and q? Now construct a equation whose roots are p and q. So t square minus p plus q into t plus pq, which is equal to 0. So t square plus 17t minus 20 is equal to 0. So this is a equation in t. Now simplify, we get the value of t, which is 20 by 3, 1 root, and second is minus 1. Now one value is p and second is q. So I take p is equal to minus 1 and q is equal to 20 by 3. So the given quadratic equations are, if p is minus 1, which is a sum of root, x square, so minus 1, so plus x, so it is minus x plus product 1 equal to 0, x square plus 20 by 3x plus product 4, which is equal to 0. Now simplify these equation. So this is a x square minus x plus 1 equal to 0. So this is a 3x square plus 20x plus 4 equal to 0. So two roots from this equation, which is a 1 plus minus under root 3 iota by 2, and two root are from this equation, so which is equal to minus 6 and minus 2 by 3. So these are the four roots. So required roots are not required roots. So the roots are 1 plus minus under root 3 iota by 2 minus 6 and minus 2 by 3. So this is our result and this is our answer. So in this way we can find the root of a biquadratic equation. Now the statement of the next question is, solve the equation x raised to power 4 plus 5x raised to power 3 minus 30x raised to power 2 and then minus 40x plus 64 equal to 0, and whose roots are in GP, geometrically progression. So solve this equation whose roots are in GP. Now, as we know that the roots of GP, so AR square, AR 4. This is the product of two root. This is AR square, AR 3. So common ratio is R. First term is A. Now product of two roots and product of these two roots are equal. So remember that in GP series, product of two root is equal to product of other two roots. Now solution. So the given equation, which is x4 plus 5x cube minus 30x square minus 40x plus 64, which is equal to 0. Now by using the beta formula, product of four roots, because it has four roots, so product of four root minus 1 raised to power 4, 64 by 1, so this is a 64. So product of four roots is equal to this. Now by given, since roots are in GP, so product of two roots is equal to product of other two roots. So let assume its roots are alpha, beta, gamma, delta. So let alpha, beta, gamma, delta be roots of equation 1. So alpha, beta and gamma, delta, they are equal, and this value assume equal to k. Now product of four roots, which is alpha, beta, gamma, delta, is equal to 64. So it implies k square equal to 64 and k is equal to plus minus 8. So I take a positive term. So this is equal to 8. So I am taking k is equal to 8. So if k is equal to 8, so we find the product. So assume, just suppose sum of alpha beta, which is equal to minus p, and sum of gamma delta, which is equal to minus q. Now we get two quadratic equation. One is x square plus px plus 8. Second is x square plus qx plus 8, right? So this product is basically equation number 1. Now simplify x raised to power 4. This is now cubic equation, which is p plus q x raised to power 3. If I multiply this with this and this with this, so we get a cubic equation. Now x square, so this is pq, then 8 plus 8, 16 into x square, 8 this and this plus pq. These are three terms. Now x, so 8px and 8qx, so 8p plus q into x plus 64. Now comparing these equation with given equation with equation number 1, so what we get, p plus q, which is a coefficient of x cube, so this will be equal to -5. Similarly, pq plus 16, so which is a coefficient of x square, so which is a 10, and next is 8 times p plus q, so which is a coefficient of x, so this is a -10. So this is a -10. So first is p plus q, which is equal to -5, and next is pq plus this is pq plus 2k, so that is a 16, which is equal to 10, and third is k, which is 8 into p plus q, which is equal to -10. So this value is equal to this is our equation. Now what is the value of k? Here it is a, so what we get, p plus q, which is equal to, this is p plus q, this value is equal to, k is -8. If k is +8, ja k is -8, so this value, then we have the two value, so this is a p plus q equal to 5, and pq, which is equal to minus positive this values. So which k satisfy the given equation? So I will choose a k equal to -8. So k is -8. So this is if k is equal to -8, then this value will become, this is a k square 64, no problem. So this is a pq, which is equal to -30 -16. So if this is -8, so plus this value is, here it is minus. So if it is minus, it is a plus. So this value will become -14. -14. So this is a PQ product which is equal to -14. So from this we can find the value of P and Q, right, by forming the quadratic equation, and that value will be 7 and -2. So one is 7, second is -2. Then solve the given quadratic equation. We get the root of equation is -8, 4 and 2, and -2 and 1. So just simplify, we will get the our resultant, our answer, our result. So in this way we can solve this equation. Solve equation x raised to power 4 minus 5 x raised to power 3 plus 10 x raised to power 2 minus 10x plus 4 equal to 0. The product of two roots, whose roots are whose roots are in GP. So in the GP, the product of two root is equal to product of the other two roots. Solution. Let alpha, beta, gamma and delta be roots of equation number 1. So this is the equation number 1. Since roots are in GP, so product of two root is equal to product of other two. So say it as K, which is equation number 1. Now, if I take alpha plus delta, which is equal to minus P, beta plus gamma, which is equal to minus Q, so I find the equation number 1 is equal to product of two quadratic equation. One is x square plus bx plus k, and second is x square plus qx plus k. Now simplify and compare with the equation number 1. X raised to power 4 plus p plus q x raised to power 3. Now p plus q, now coefficient of x square, which is pq plus 2k x square, and third is coefficient of x. So coefficient of x is k common p plus q into x plus k square, this value. Now comparing these equation with equation number 1. So first p plus q, this value, which is equal to minus 5 pq plus 2k, this will be plus 10, and next is k into p plus q, which is equal to minus 10, and last is k square equal to 4. So we get two value of k, one is plus, second is negative, plus minus 2. Now we will verify which value is applicable, either plus 2 or minus 2. Now from this value, from this, if I substitute k equal to 2, if I substitute k is equal to 2, then P plus Q equal to minus 5 from this equation. If I substitute K equal to minus 2, in that case P plus Q is equal to 5. But in our case, P plus Q is equal to minus 5. It means this K is applicable. This is not applicable because it does not satisfy this condition. So what is the value of K? So we will choose the value of K which is equal to 2. So this is very important point, just remember. So we will choose the value of K equal to 2. So it means PQ, which is plus 10 plus 4, which is equal to 10. So PQ, which is equal to 6. This is. So that is my right value. Now to find the value of P and Q, I construct a equation T square minus P plus Q into T plus PQ. So its roots are P and Q. So what is the value of P plus Q? Minus 5 and 6. So this is plus 5T plus 6 equal to 0. So that is our quadratic equation whose roots are P and Q. It implies, so this is T plus 2 into T plus 3, which is equal to 0. So T is equal to minus 2 and minus 3. So one root is minus 2 and second root is minus 3, this values. So let the first root P is equal to minus 2 and Q is equal to minus 3. Now the given quadratic equation, which is 1 is x square, one is x square plus px plus k, k is 2, and second is x square plus qx plus k, k is 2. So we get two quadratic equation, x square plus px plus k, which is equal to 0. Second is x square plus qx plus k, which is equal to 0. So this is x square minus 2x plus 2 equal to 0, x square minus 3x plus 2 equal to 0. So two roots are from this equation and two are from this equation. Now this is 2 plus minus b square minus 8 square root of 2. So this will be 1 plus minus iota, 1 plus minus iota. From this 3 plus minus 9 minus 8 square root 2. So 3 plus minus 1 by 2. So which is equal to 2 and 2 and 1. So these are the four roots. So four roots are 1, 2 and 1 plus minus iota. So in this way we can solve the biquadratic equations whose roots are in GP.